In question 14, you're asked to generate the first 5 terms I should say, of the following difference equations or recursive equations. Probably easier to do these on your calculator. So what I've done here, I've gone into the sequence and series mode. I've gone on the recursive. So 2 times an, take 10, a is equal to 20, and you can quickly generate the first 6 terms. So we're going 20, 30, 50, 90, 170, 330, etc. Show them continuing. Now, if we start off with our initial term as being smaller at 5, we'll see the effect. So you can see here the effect of doubling the term and taking from 10 leads us to a decreasing sequence, if you like. Continuing that along, we'll see what happens when we start off with our initial number of 10. What we've got here is a steady state. In other words, our doubling effect taken away from 10 leaves us stuck on 10. So we call that a steady state. In D, we'll see what happens when we make that 12, but starting from 10 once again. So we're taking off 12 in this instance, and that leads us to a decreasing sequence, if you like. E looks at the effect of just halving that first term or the previous term. I'll make that 0.5 times and add 16, and we'll see the effect. Obviously, this should be an increasing one, starting at 20. Very powerful tool, your graphics calculator for this. So you can see here we're increasing, but we seem to be plateauing out. It seems to be getting closer and closer to 32 without ever exceeding 32. That's the effect of halving previous term and then adding. Initially, if we start with 20, that will be 10 plus 26. Once we've got 26, it'll be 13. Once we get to 30.5, it's getting closer and closer. In other words, leveling out or reaching an equilibrium. So if I write down the first 6 terms, this is what I get. And it might just pay to note that this actually reaches an equilibrium. I'm just going to graph that so you can actually see the effect. I'll change my scaling a little bit because clearly I want to go a little bit further than what they're suggesting. And I'll just take it through 50 and we'll see what it looks like. So you can see there, initial rise and then leveling out at 32. If I go analysis, trace, I've only run this through to 10, you can see the leveling out effect. Nice little problem though. In the last question, half n plus 6. So this is with a smaller addition. So I'll just go back to the entry point and I think I'll swap those around and we'll have a look at the table. So we'll make that 6 and we'll see what the effect is in this instance. So you can see there decreasing, but we seem to be leveling out at 12. A quick look at the graph there and you can see that leveling out effect, reaching an equilibrium at 12. I'll write down those points. Now it is possible to do more analysis than this course really goes into, as the book investigates, and the book looks at something called an asymptote. We'll call it reaching an equilibrium, And it's probably best at this level of maths just to look at it from the perspective of where your graph is leveling out at, or perhaps topping out at. And there'll be scenarios we look at later in this particular set sequence, where we want to investigate those different phenomena.